Hi everyone, welcome to this video where we will learn about Amazon QLDB. So before we begin with this video, let me give a little introduction about myself. My name is Aishwarya Sood and I am working as a lead coach into the AWS domain, and I am 3x AWS certified, AWS Academy accredited educator, and also an Amazon authorized instructor. You can connect with me on LinkedIn. My profile name is given here, and you can also scan the QR code to directly view my profile. So what we are going to discuss in today's video is we will start with discussing what are ledgers and what is Amazon QLDB, that is Quantum Ledger Database, and why is it even needed, what are the core concepts that come within it, and how is it compared with the relational databases that are available, what are a few features of it, what are the benefits of it, and we will also discuss a few use cases of it and a few customer stories, and then we will see how it works on the AWS Console, how to set up it, how to get started with it. So let's begin with the first topic for today and understand what's a ledger and what are ledger databases. So a very straightforward definition of ledger says that it is a book or collection of accounts in which account transactions are recorded. Yes, the ledgers are typically used to record a history of economical and financial activity in an organization. Many organizations build the applications with the ledger-like functionality because they want to maintain an accurate history of their application's data. For example, they might want to track the history of credits and the debits in banking transactions, verify the data lineage of an insurance claim, or trace the movement of an item in a supply chain network. And these ledger applications are often implemented using custom audit tables or the audit trails created in the relational databases. So we will learn more in detail about the ledger databases by understanding the basics of Amazon QLDB. But why is it important? Given the time period that we are living in, there is a serious lack of trust. There is a lack of trust in relationships and a lack of trust in the technology systems as well. As of recent, there is a serious lack of trust in how companies use our data. Anyone can create a system for tracking how the data is being used, but how can they legally prove that the data has not been altered? Even with the best UI audit tracking, an engineer can go directly to the DB or the document and alter a record without leaving a trace. This type of system can be used to build trust with the customer or with other business units. It can be used to ensure the policy, governance, and the regulation of data or processes also. Anything that you want to store and be assured that it hasn't changed is a good candidate for such a ledger database. So let's understand what is Amazon QLDB. As I told you a bit about what ledgers are, we will discuss basics of about what is Amazon QLDB and how to use a ledger database on AWS. And for this itself, we have Amazon QLDB, which stands for Quantum Ledger Database. So this is a fully managed ledger database that provides a transparent, immutable, and cryptographically verifiable transaction log that is owned by a central trusted authority. Fully managed means we don't have to worry about all the administrative tasks. They will be taken care by the service itself. With the QLDB, the history of changes to your data is immutable, which means it can't be altered at all, updated or deleted as well, nothing. And using cryptography, you can easily verify that there have been no unintended changes to your application's data. QLDB uses an immutable transaction log, which is known as a journal, about which we will be learning a little bit later on. This journal is basically an append only and is composed of a sequenced and hash chained set of blocks that contain your committed data. And you can use Amazon QLDB to track all the application data changes and maintain a complete and verifiable history of changes over the time. So let's continue our discussion a little further for why there's a need of ledger as a database. Actually, traditional databases allow you to overwrite or delete the data, so developers use techniques such as audit tables and the audit trails to help track the data lineage. While these approaches can work, they still require some custom development and can be difficult to scale and put the duty on the application developer to ensure all the right data is being recorded, which is quite time consuming. But data in Amazon QLDB is written to an append only journal that I also told previously. which means we are not going to have our data altered or overwritten, providing the developer with full data lineage. Moreover, the data that is here in Amazon QLDB's general is immutable and verifiable, which means you can trust the data that is there in your ledger, of course. And Amazon QLDB's feature make it a natural fit for the system of record applications, those for which the data integrity and completeness and the verifiability are critical. So such applications are a good case where when the QLDB can be used. For example, in a supply chain and logistics space, an application that is built on Amazon QLDB would have the entire history of changes, such as movement between the carriers and across the borders, available for query and analysis. In finance, the system of record applications track the critical data such as credit and debit transactions, and instead of building complex record keeping functionality within their application, banks can directly use a QLDB to easily store a permanent and complete record of all the financial transactions that are happening. And also QLDB is fully managed, as I just told you, and automatically scales to meet the needs of your application with no provisioning required at all, because again the reason is that because it is fully managed. Let's now discuss a few core concepts and the components that come within it when we start working with the Amazon QLDB. So we will be just discussing all the basics of QLDB in this video. We are not going to dive deep into anything much about it. That's why we will just discuss an overview of the things over here. So the ledger is here first of all. In QLDB, the very first step is to create a ledger, which is a primary AWS resource type for the QLDB that we will see how to create in the AWS console. And to start writing data in the QLDB ledger, you first create a table with the basic create table statement, like how we do generally. Ledger data will consist of revisions of documents that are committed to the ledger's general, and you will then commit the document revisions to the ledger in the context of a user defined tables. In QLDB, a table basically represents a materialized view of a collection of document revisions from the journal itself, and table consists of revision of the QLDB documents, which are the data sets in Amazon Ion struct format, and a document revision basically just represent a single version of a sequence of documents that are identified by a unique document ID, and QLDB will store the complete change history of your committed documents that you have committed here. And each ledger provides a system defined catalog resource that you can query to list all of the tables and indexes in a ledger. Let's see a little bit about how this works. So this QLDB is fully managed, and it provides transparent, immutable, cryptographically verifiable transaction log. That is what we have been discussing till now. Now how it works is like you can see, let's say we have some application data, basically like credit and debit transactions, some insurance claim history, or some supply chain asset tracking, or some vehicle records, and it can be anything else as well. QLDB takes it all up, and then there's a journal which is append only, where it is all contained, okay, which it contains it as a sequenced cryptographically verifiable entry of each change that is made to the data, and changes are then chained together as blocks. For example, the credits that have happened, the debits that have happened, they are chained together in the form of blocks. And what else it stores? It stores the current value and the historical state of your data. For example, the current value of your bank account and its history, whatever transactions have happened, all the credits, debits that have happened, all of that data is stored here. Basically the current history and the current state and the history of it. Then what we can do by on this data and the transaction logs, what we can do there, we can access a complete history of the changes that has been made to our data, and we can cryptographically verify the change history of our data, that it has not been altered by any user. It has not been overwritten. It is like the real one only. So that is how basically it works in a higher level. Now, what does it mean when we say that it is general first? Okay, when we say that QLDB is journal first. So let's understand this. Basically, in a traditional database architecture, you write the data in the tables as a part of a transaction. A transaction log, which is typically an internal implementation, which is the record of all the transactions and the database modifications that they make. The transaction log is also a critical component of the database, and you need to log to replay the transactions in the event of a system failure, disaster recovery, or data replication. But the database transaction logs aren't immutable and aren't designed to provide direct and easy access to the users, because they can be changed. But in Amazon QLDB, the journal is the core of the database. Structurally similar to a transaction log, the journal is an immutable append-only data structure that stores your application data along with the associated metadata as well. All the write transactions, including all the updates and even the deletes, are committed to the journal first. And QLDB uses a journal to determine the current state of your ledger data by materializing it into a queryable user-defined tables. And these tables also provide an accessible history of all the transaction data, including the document revisions and the metadata as well. In addition, the journal handles the concurrency, sequencing, cryptographic verification and availability of the ledger data. You can see that in the diagram as well. So we will understand the diagram a little bit more in the next few seconds. QLDB also allows you to access and manipulate your data using PartyQL. Okay, so this is what is used in QLDB, which is nothing but an open standard query language that supports the SQL compatible access to the QLDB's document oriented data model that is including the semi-structured and the nested data while remaining independent of any particular data source. And this diagram, we can see an example here where it is showing that there is an application that connects to a ledger and runs the transactions that inserts, update and delete a document into table named cards. You can see here the data is first written into the journal in a sequenced order. Then the data is materialized into the table with the built-in views. And these views let you query both the current state and the complete history of the car, with each revision assigned a version number. You can see here different version number. Whenever there was a change made, it is recorded into it. And you can also export or stream the data directly from the journal itself. When it is here, you can export from here itself, or maybe you want to stream, you can do that as well. And also it is immutable because the QLDB journal is append only. It keeps a full record of all the changes to your data that can't be deleted, modified or overwritten. And there are no APIs or other methods to alter any committed data in place. And this enables you to access and query the full history, that is a real history, the unmodified one of your ledger. QLDB writes one or more blocks to the journal in a transaction, and each block contains entry objects that represent the documents that you insert, update and delete, along with the statements that you ran to commit them. Also, these blocks are sequenced and hash chained to guarantee the data integrity. So you can see in this diagram, which illustrates a journal structure, it shows that the transactions are committed to the journal as blocks, as you can see here, that are hash chained for verification. You can see here, and each block has a sequence number. You can see 789, 790, 791 that specify its address. Also, the journal blocks are sequenced and chained together with the cryptographic hashing techniques similar to the blockchains. So this feature enables a journal to provide transactional data integrity using a cryptographic verification method. Using a digest, which is nothing but a hash value that will represent a journal's full hash chain as of a point in time, and a Merkle audit proof, which is a mechanism that proves the validity of any node within a binary hash tree. By this, you can verify that there have been no unintended changes to your data at any time. So you can have a look at this diagram. This diagram shows a digest that covers a journal's full hash chain at a point in time, and the journal blocks are hashed using the SHA-256 cryptographic hash function and are sequentially changed to the subsequent blocks. And each block contains the entries that include your data documents, metadata and the PartyQL statements that ran in the transaction. So let's just discuss a few more features of this QLDB, and then quickly we will move on to the console, seeing that how the QLDB sets up. So as I told you, QLDB uses a PartyQL as its query language and Amazon Iron as its document-oriented data model. PartyQL is nothing but an open source SQL compatible query language that has been extended to work with Iron. And with PartyQL, you can insert, query and manage your data with familiar SQL operators itself. When you are querying the flat documents, the syntax is the same as using the SQL to query your relational tables, and that is like most of the people are familiar with that syntax itself. To simplify the application development, QLDB provides open source drivers in various programming languages, and you can use these drivers to interact with the transactional data API by running a PartyQL statement on a ledger and processing the results of those statements. Also, QLDB is fully managed, serverless and highly available. Since it is fully managed, it means the service automatically scales to support the demands of your application, and you don't need to provision the instances or capacity because it is serverless also. Multiple copies of your data are replicated within an availability zone and across the multiple availability zones in an AWS region. So you can see this diagram shows the mapping constructs of the core components between a traditional relational database and the Amazon QLDB. This table shows the primary high level similarities and the differences of built-in operational features between a traditional database and the QLDB. So for this, you can check out the core components mapping. Here you can check out the similarities and the differences. Like for example, let's say in relational databases we call a database. The same thing here we call in QLDB as a ledger. The table is there, which we call the same table here also. Index is also index. Table row is the Amazon Iron document here. Column is the document attribute here. SQL is replaced with the PartyQL here, and audit logs are replaced with the journal here. And more similarities and differences you can read from here in this table. Like for creating the tables, what things come up, for deleting, querying, for updating, for the metadata, multiple things are there, so that you can get a more understanding between like how this relational databases and QLDB is compared with each other. So now let's go ahead to the AWS console and see how to work with the QLDB. Basically, how to get started with QLDB. We will not be doing anything complex with it as of now in this video, because this topic is just created in keeping in mind the audience is a beginner audience, and we will be just having a getting started demo for this QLDB. So first of all, we just have to search for QLDB. Then let's go to the console of Amazon QLDB. So as you can see, QLDB is not supported in all of the regions as of now, and since my region was selected as Mumbai, it's not available in Mumbai as well. So what I'll do, I'll change the region to North Virginia, and there we will work on the Amazon QLDB. So as you can see, there are no ledgers created as of now here. We will create a new ledger, and I will just create a sample ledger for which I got the data in the documentation itself. I'll go ahead with the same ledger here as well. That is vehicle registration. After giving the ledger name, we can specify the permissions mode. So we can see here two permission modes are given: standard and allow all. Allow all is the legacy permission mechanism, and standard is a new one and is a recommended one. So if you think that you have to follow the principle of least privilege, then you should go for the standard permissions only, but otherwise you can take the allow all as well. So, but anyway, this is not recommended because this is granting all the permissions, and it allows all the PartyQL commands also to run, and doesn't allow table specific access control. But on the contrary, when we look at the standard permission mode, in this mode we can write the IAM policies that grant or deny the permissions to specific ledgers, tables, API actions and the PartyQL commands. Basically, we are getting more fine-grained access control when we select the standard permission mode. So if you need fine-grained permissions, and of course that is recommended, you should go for the standard permissions mode. Then for the encryption of data at rest, it uses a KMS for that. You can choose a different AWS key. Okay, if you have a key that is created or you want to have another key, you can use it here. Otherwise you can use a AWS owned key. That is a more simple option. So for this demo I will not a different AWS KMS key. Okay, I'll just go ahead with the AWS owned key only. You can add the tags over here. Tags just for better filtering and management of the resources. You can add the tags over here. Right now I don't need any tag with my ledger, so I'll just go ahead and create the ledger. Okay, so it will take a few minutes to become active. Okay, just 2 to 5 minutes usually it takes. So we will wait for it to become active and then we will proceed with the further steps. So you can see the ledger is now into the active status, which means we can work on it now. We can create the tables, indexes and all other things with to our ledger now. Apart from ledgers, you can see there's a query editor where we can run all the queries. Okay, we just have to choose a ledger and we will be running all the queries over here. Okay, but right now there are no tables, that's why it is showing like this. We will be creating and then we will be coming up onto the queries. It will show all the recent queries, any queries that we have saved, everything will be visible here. Apart from this, there are streams that are available. We can create a stream from our journal which will continuously write the data to the Kinesis data streams from your journal in the near real time. So that streams can be processed by Kinesis and take further action based on the data contents if you need that. So you can create it from here. You can also export your data, okay, the journal blocks that you have got here for various purposes, maybe including the verification, for analytics, for auditing, backup and exporting to other systems. So maybe if you have a case line where you want to export your journal data, you can do so from this option. Then for the verification, when you want to cryptographically verify the data here that it has not been changed and it is the real one, then you can verify it from here. Right now what we will do, we will create a table and indexes in our ledger that we have created, the vehicle registration. So for this particular demo, we will be just loading the sample data into it and we will not be adding the data manually. We just have to go on to getting started and I have got the data here. I just have to click on the ledger that I want to load the sample data in, vehicle registration. Okay, then I will load the sample data. And once it shows that the status is done, that it has loaded sample data, we can proceed with the further step. So you can see it is saying that the sample data has been loaded. So this script runs all the statements in a single transaction only. If any part of the transaction fails while loading the sample data, every statement is rolled back and an appropriate error message will be then displayed. Then you can retry the operation after addressing whatever issue it is telling. You can just troubleshoot that and then you can work on it. So what data is there into this sample data that has been loaded? It contains the data about the vehicles, their owners, their registration information. So where I have got this data, this is just a sample data. You can read more details about this data in the documentation. It is given for the same example, it is given in the documentation. Okay, that's why for getting started, I just chose this example only. So what are the tables that it will be creating? You can check vehicle registration, vehicle, person and the driver license is what are the 4 tables that it is going to create. And here it is also creating these indexes, the vehicle registration table. 2 indexes are creating in this, the VIN and the license plate number. Then for vehicle table, the person table, the driver's license table. These are the fields that are getting created. So now the tables are created, the data has been loaded into it. Now we will query those tables for the data and we will perform some modifications and then we will see if we want to verify that. So now you can see vehicle registration ledger has been selected. 4 tables are selected there and it has these indexes that I showed you on that page and we will run a query over there now. So the first query that I'll be running is to query the vehicle table that is there to get the information for a specified VIN, that is a vehicle identification number. So for this particular number, I'll be getting the information. Let's just click on run. You can see our query has been processed and I have got the results like this, that with this vehicle identification number, the type of the car is, the vehicle is sedan and year is 2011, for registration make is Audi and model is A5 and color is silver. This all details I have got from this query. Now I will run one more query where I will be using the joins. So what we will do, we will use a join to join the vehicle and the vehicle registration table, the data we want from here also, so that it returns the registration information along with the attributes of the registered vehicle for a specified VIN, that is this. So let's run that query now. You can see we will be returning the information, the registration information as well as other attributes that we can see here from two tables, the vehicle and the vehicle registration. Let me run this query now. So you can see in the result what I have got here, the VIN for which I was looking the data is this, and what data I was looking, the license plate number, state, city, owners. So let me check if it is there. Yes, the license plate number has been returned, state is returned, city also, and the owners also is returned. Okay, so here I have got this data. So that's how we query our data in the QLDB. Now that we have got some data, now what we can do is we can make some modifications to our data. In the example that I have got here for the vehicle registration, what modifications we can do is, let's say the car that was Audi A5 with the vehicle identification number, this one is this is initially owned by a driver that is named Raul Lewis in the Seattle and Washington. Okay, suppose that this person sells the car to a resident in Everett, Washington named Brent. Okay, then the Brent and Alexis decide to get married, and Brent wants to add Alexis as a secondary owner on the registration. So in this step, what we will do is we will just make the appropriate modifications as per the example that I have explained you. You can read more about this example in the documentation. Okay, I'll be just performing the same thing over here. So we just make the modifications accordingly to change the ownerships. Initially, it is named with the name of Raul, and we are gonna change the ownership from Raul to the Brent. Okay, and then Brent will be the primary owner, and the Alexis with whom the Brent is getting married, Alexis will be having the secondary ownership. So that same modification we are gonna make here. So first of all, what we have to do is to transfer the vehicle ownership to the Brent in the city of Everett. We have to first find its ID from the person table with the statement. Okay, that I'll just give here. This is a person table. Here the Brent is ID it's located. So let me give the correct statement. Okay. So we have to just replace this with Brent, and he is in Logan. So let me run this. So you can see I have got Brent's ID from the relevant table. Okay, now this ID we will use to update his details. The ownership, okay, the primary owner we will be adding as Brent, and also the city in the vehicle registration table. So let me give the appropriate command for updating the details. Here we have to replace our ID this with the Brent's ID that we got from the previous query. So let's give his ID over here, and then we will run the command to update it. So you can see it was nothing but we were updating the vehicle registration table, and here we were updating the owner's primary ownership with the person ID this, okay, city equals to this, and where the vehicle identification number was this, where initially the primary owner was Raul. Okay, so you can see for this query it is showing the status as success. That means it has been done, but we will just confirm it once. So for confirming, we will just fetch the same from the vehicle registration table just to check that with this vehicle identification number now whose details are populated, just to confirm that. So you can see I have run this query, and what I have got is the person ID is this, and if you remember, if you would have noticed, this is a person ID for Brent, and the city is Everett. That means our data has been updated successfully in the vehicle registration table. Now one primary ownership has been added with the name of Brent. Now his wife Alexis, we will be adding the secondary ownership. For that we first have to find her ID from this table person. Then run this command and let's see, we have got this ID. Yes, so we have got this ID for Alexis. We will be using this ID now to update the ownership for the secondary ownership for the same car. So let's run the query for adding Alexis as a secondary owner into the car. So we have to enter the ID for Alexis here. The ID was this. Let's copy this and give it here in the person ID, and here we go. Let's run this command. So let's check if it is successful. Let me check. Yes, the status says it is success, but we will anyway confirm by fetching the relevant details from the table. So we are fetching the secondary owner from the same vehicle identification number that we have been using till now. So the query has been processed, and you can see this is a person ID which was Alexis person ID, which means the secondary owner for this vehicle is now Alexis. So that means our modifications are successful now. So now the modifications have been made to our data. Now what we can do is we can verify the history, the revision history for our data that we have been just modifying. So here we can query the history of all the registered owners and any other updated fields for the same vehicles, and you can see all the revisions of a document that we inserted, the updation was done, and also anything that has been deleted. There is a built-in history function. By using that itself we can check out all the revision history for our table. This history function, what it will return is basically the revisions from the committed view of our table, and which includes the application data and the associated metadata also. The metadata will include when each revision was made, in what order it was made, and which transaction committed them. So let's just go ahead and verify the revision history for that. So first of all, we will query the revision history of our document in the vehicle registration table in the vehicle registration ledger itself. But first of all, before querying the history of our document, we have to find the unique ID of our document. For that, the command that is needed is this. Okay, so we are just fetching the ID, the unique ID of our document. Let's just note that. So you can see here we have got it. Now this ID we will be using to query the history function, for which we will run this command. Okay, so we just have to replace this with our ID that we have got from the previous command. Okay, let's copy this ID and give it here so that we can check the revision history for this. Now let me just run this command. So let's have a look at the results that it has given to us. You can see the revision history. With this same vehicle identification number, first the entry was made with the city of Seattle. If you remember, Raul was added into this the vehicle identification number. He was a primary owner in this. So the person ID for him is shown here. Secondary owner was none. Then we made the modification when we gave this primary ownership to Brent, because this person sold his car to Brent, who is a person living in the city of Everett. So now the primary owner, the person ID is of Brent, okay, and secondary owner still it is none. Then what we did, we added his wife Alexis as a secondary owner, which is also living in the same city, Everett, and now the primary owner is same. This is Brent's ID, and secondary owner, this is Alexis ID. So this is a whole revision history. All the revisions have been made like this. So you can verify from here. So now we have checked the revision history. We can also check the metadata of the same. Okay, like when the revisions were made. For that we have this command. Okay, we just have to replace this random ID with our metadata ID. So let's copy this and give it here, and let's just clear this. Okay, so we will now run this command and we'll see what's the result for us. So the command has been processed, and let's have a look at the results. You can check for this metadata ID which I have given here, the version 0. Okay, the transaction ID is given here, the transaction time is also. This was the version 0 when the car's primary owner was Raul. Okay, so you can see it is giving the time also, the previous one 12:41 and the UTC time. Then the first version, you can see on the same date 12:55 I added the primary owner, so a revision was made, okay, which with the transaction ID this, and this was a transaction time. Then a second version was made when, if you remember, when we added the ownership, the secondary ownership for LXS, so that made it to version 2, okay, for which the transaction time was this and the transaction ID was this. So this is how we get started with the Amazon QLDB. You can explore it more. This was just a basic functionality that I just demonstrated here. You can explore more features of it. You can even do the verification, the cryptographic verification if you want. Okay, for that what you have to do is just select this vehicle registration ledger, okay, and give these details, the document ID and the block address of it. Then choose a digest, which it will give you after, you know, getting from here. You just have to go to the ledgers, select this one, and then let's just wait for it to open. Yeah, you just have to click on get digest, okay, it will load. You just have to save it. Here you get the digest TIP address, okay. So this document will be saved when you click on save, so it will be saved in your local system. Then you just have to go to verification, okay, and then you have to enter the relevant details, choose a digest, upload that document, and then verify. Then it will give you all the verification results as well. So this is how you can work with it. I hope you have got the basic idea of it. Now let's go back to our slides and finish our session. Let's just discuss a few use cases of it, and I will just show you 1 or 2 customer stories for it, and then we will wrap up the session. So we can create a complete and accurate record of all the financial transactions, such as all the credit and debit transactions, which we have been discussing previously also, and that's a good candidate for like Amazon QLDB. We can also record the history of each transaction and provide the details of every batch that is manufactured, shipped, stored and sold from the facility to the store. And we can also use it for this, for reconciling the supply chain system, where we can track a claim over its lifetime and cryptographically verify the data integrity to make the application resilient against data entry errors and the manipulation. Also, we can implement a system of record application to create a complete centralized record of employee details such as payroll, bonus and the benefits. So let's have a look at a few of the QLDB customers and let's see what are they saying about it. Okay, so we will have a look here. One for the Liberty Mutual Insurance. So what they are saying, we leverage Amazon QLDB as an integrated single source of truth data platform. Okay, they have got many benefits after using QLDB, and they are saying using AWS QLDB's high velocity streaming capabilities, real-time data flow is enabled across the enterprise, and a lot more benefits that they are getting with this. Okay, so you can also see, yeah, one more thing I wanted to tell you. See this. When combined with AWS serverless ecosystem, this QLDB is a catalyst for decomposing the monolithic legacy processes into fine-grained agile functions. So it is, you know, making the processes agile, easy and smooth for these kind of organizations. And Splunk, the organization who asks, which helps organizations ask the questions, get the answers and take actions and achieve the business outcomes from their data. So what they have got from the QLDB is that they say, first of all, they say that data is a strategic asset that organizations rely upon to operate and succeed. And yes, that's true for all the organization, right? Data is so important. And what they say is that they are excited about the potential of Amazon QLDB, which provides a way to trust and verify the integrity of data without the complexity of operating a blockchain network, right? Because you also have seen that how easy was it to work with the Amazon QLDB. Similarly, these organizations are also taking the benefit of similar features. You can read about more customer stories here to read that how it is benefiting these organizations. Okay, so that was just 2 or 3 of them that I wanted to let you know. Okay, and I hope you have understood all the basics of QLDB that we have discussed today. Let's meet in the next video now. Thank you.